Welcome to qnawire.
In order to calculate the average velocities, we're going to need the velocity at the start and the end of the 4.75 second part. So if we assume that our initial velocity is 0 when the rocket's on the ground, we're trying to solve for the final velocity after the 1.15 seconds. So that'll be our unknown. The time will be 1.15 seconds, and the distance traveled during the initial 1.15 seconds is 63 meters. Now we're going to use the kinematic equation x minus x naught is equal to 1/2 v naught plus v times t. Whenever we plug in these values, we get 63 is equal to 1/2. In this case, v naught is 0, so that term goes away. So we're just left with v times 1.15. Solving for v yields 109.57 meters per second. So this is the velocity at the beginning of the 4.75 second part. Now we need the velocity at the end of the 4.75 second part. And to do this, we'll treat this velocity as the initial velocity and then calculate the new final velocity. So now v naught is equal to 109.57 meters per second. This is again our unknown. In this case, t is equal to 4.75 seconds. And x minus x naught is equal to 1,000 minus 63, because that's the new distance traveled by the rocket during the 4.75 second. If it ends at 1,000 and it went 63 the first time, then it went the difference during the 4.75 second part. This is equal to 937 meters. And now we're going to use the same kinematic equation. X minus x naught is equal to 1/2 v naught plus v times t. And we're going to plug in, so we get 937 is equal to 1/2. V naught is now no longer 0, it's 109.57 plus v times 4.75. Our unknown is v, and this is just an algebraic equation at this point. Solving it gives v is equal to 284.96 meters per second. And now we can actually start to calculate the things we need to calculate. So for the 4.75 second part, the average velocity is the final velocity, which is 284.96, right, this guy, minus the initial velocity, which is 109.57. And we divide by the time that took, which is 4.75 seconds. And I get 36.92 meters per second. I'm going to do the other part on the next page. So for part B, we need the full 5.9 seconds, including the beginning of the takeoff and then the 4.75 second part. So for full 5.9 second, the average velocity is equal to the final velocity, which is still 284.96. But now the initial velocity is 0, because originally at the beginning of the 5.9 seconds, it was moving at 0 velocity. And then the time it takes is 5.9 seconds. And what I get is 48.3 meters per second, which is the answer to part B.